In this video, we're going to discuss Python dictionaries. A dictionary is a mapping type which maps keys to values. The keys of a dictionary are any hashable value, and the values can be of any type. So in the graphic here, we see that a dictionary is defined using curly braces, and between those braces, we have a comma-separated list of key value pairs, where each key value pair is separated by a colon. The picture that follows shows that the keys, the strings A, B, and C here, are used to point to or map to the set of values, which are 1, 2, and 3 in this example. So I said that keys must be hashable. And for our purposes here, it's sufficient to think of hashable as a mapping from an object to a unique ID of some sort. Objects that can change during their lifetimes, mutable objects for instance, do not map to a single unique ID and can therefore not be used as keys in a dictionary. For a description of Hashable, I encourage you to check out the link to the Python glossary here, as well as the documentation on the hash function itself, which can be found here. Now, to create a dictionary, we already saw in the graphic above that we could use curly braces to wrap a list of key value pairs. So I can create a dictionary of usernames and user IDs as follows. User ID equals, I'll open curly brace, and then I'm going to use usernames as keys. So the string Tom, followed by a colon, and then maybe the ID 1, 2, 3, 4, 5. And then maybe Bob with his user ID of 67890. And so now we have a dictionary with two entries. In fact, we can use the length function to verify that we do indeed have two entries. Now, in addition to using curly braces, we can also use the dictionary function itself to create dictionaries. The dictionary function does have a few options. One is to pass an iterable of tuples containing the key value pairs. So for example, we say dict, and then for the argument list, we'll pass a list, which will be our iterable. And this list will contain two tuples, one for Tom with his username and ID, and then one for Bob with his username and ID. And you see this creates the same dictionary as above. Now, instead of using an iterable to generate our dictionary with this function, we can actually pass any number of keyword arguments to this function to create a dictionary as well. But this only works if the keys to our dictionary are simple strings. So I can write the dict function again, and instead of the iterable, I'm going to write Tom equals 1, 2, 3, 4, 5, and then Bob equals 67890. And you see that this is equivalent to the previous two examples. And notice that the keyword arguments here, Tom and Bob, obviously don't exist as formal parameters in the dictionary function, and the function itself is using them to create the keys in the dictionary. Dictionaries differ from sequences like lists in that they can be indexed, but not by integers. Since dictionaries themselves are unordered, we actually have to use the keys to index them. So I'll write our dictionary name user ID, and for indexing, we're still going to use square brackets as we did with the sequence types. But instead of the integer index, we're going to use one of the keys. So Bob in this example. And when I run the block, you see we get the value associated with that index. Now we can use indexing to add or modify the elements in a dictionary. But if I attempt to bind a value to an index that doesn't exist, this will actually create that entry in the dictionary. In effect, it will add the key value pair. So in this example, Sam with the number 93846 to the dictionary. But if we attempted to access a key that doesn't appear in the dictionary without binding it as we did in the previous example, you'll see that we get a key error, letting us know that the key John did not appear in our dictionary. Dictionaries have a couple of methods that can be used to iterate through their elements. So if you need to iterate over all the keys of a dictionary, the keys method will return an iterable that can be used in a for loop. So I can write for k in user ID dot keys, and we can simply print k. And you'll see that this outputs each of the keys from the dictionary, one per line. Now, similarly, the values method can be used to get all of the values from our dictionary. So we use a similar for loop using the values method, and we get each of the values, one per line here. Now, if you happen to need both the keys and the values, then the items method will return tuples containing both keys and values. And so you can see we can print both of those as well. Now, as we saw in the List Revisited notebook, the dell statement can be used to remove or delete items. First, let's remind ourselves of the contents. So we can actually remove the key Sam and its associated value by simply writing dell, user ID, and then the index Sam. Also, the in keyword can be used for membership testing. So we can check if a particular key is in the dictionary by simply writing Tom, for instance, in user ID. And of course, we can see that Tom is a key in this dictionary, and so this returns true. And obviously, if you try a key that does not exist, this would return false. Now, notice that it's operating on keys and not values. And so if I tried to test for 1, 2, 3, 4, 5 in user ID, we get back false, even though this is a value in the dictionary. However, if we did want to test for a particular value, we could use the values function once again. And so you see we get true here in this case. Dictionaries can also be created using comprehensions. So dictionary comprehensions work exactly as they did for lists and sets. And so I won't go into all the details here. In fact, if you do need a refresher, please check out the List Revisited notebook in the Data Structures chapter. Now, similar to a set comprehension, a dictionary comprehension uses curly braces and places square brackets when defining the comprehension. However, to differentiate it from a set comprehension, we must use key value pairs separated by a colon in the target expression. So for example, if we wanted to create a dictionary that used integers as keys and their squared values as the values in the dictionary, we could write a comprehension as follows. Open our curly braces, write x, and then a colon, and then we'll write x squared. And then we'll say for x and say the tuple 2, 4, 6. And you see we get a dictionary containing the integers 2, 4, and 6 as keys with squared values 4, 16, and 36. We could even recreate our user ID dictionary from the examples above using a comprehension. To do so, we would define two lists, one of usernames, which will be our keys, and one of user IDs, which will be our values. And so I'm going to paste two lists, namely names and IDs. And then the next line, I'm going to open curly braces for our comprehension. I'm going to write x colon y. And then we'll say for x and y and we'll use the zip function here to iterate through both the names and IDs lists. And when we run the block, you see that we get a dictionary containing the keys, Tom, Bob, and Sam, with their user IDs coming from the list of IDs. Now, as a final example in this notebook, I've included some code here that will randomly generate a graph of 2D points. Now, I'm using this particular example here because directed graphs are commonly stored in a data structure that resembles a dictionary. So the keys in this case would be the nodes or points in the graph, and the values would be the list of edges emanating from each of those keys or nodes. Now, I will say that if you're working on graph problems, there are a number of modules that provide a great deal of functionality and will make your life much easier, like NetworkX or PyDot. So you're not going to need to reinvent the wheel here. But hopefully this gives you a more interesting example to view than the sort of artificial usernames and IDs that we had above. So the line here randomly creates a set of 2D points. And as I said, these will be the nodes in our graph. And we're actually going to use the indices of these points in this list as the keys in our dictionary. So in the for loop here, we're adding the index of each point as a key to the dictionary. And that index is represented by I here. And for the value, we're going to create a list whose length will be equal to the valency of the node. Now we're fixing that value to be 2 here. And the random choice function will choose two values from the list that we pass it. And those values themselves will also be indices back into our points list. So in essence, this is going to be our edge list where we're adding two edges from every key to two other randomly selected points in the graph. And the last loop here is actually going to generate the plot or figure depicting our randomly generated graph. So if we run this, you see that we get 10 2D points where every point has two edges pointing away from it. And this is signified by the line segment ending in a blue arrow. Now, if you were to run this multiple times, since the 2D points and the edges between them are all randomly selected, you should see different outputs here. Now, there's not much to this, but hopefully this does give you a somewhat more interesting example to consider on how dictionaries can actually be used.